welcome to lesson 29, the workbook, since there is not a checkpoint section. So, a shoe company wants to design an advertisement to be printed on half of a hot air balloon. Which measure would be most helpful for the company to consider when designing the banner? Okay, if you're on a hot air balloon, it has a relative shape like this, but you're going to be on the outside of your advertisement. So they should worry about a surface area because that's what is defined to be the outside area of a shape. Question 2. A standard soccer ball is 22 centimeters in diameter. What is the volume of a standard soccer ball? Okay, so I'm going to use a spherish looking thing to demonstrate. Diameter would be 22. So this entire length right here is 22 centimeters in diameter. And the volume of a sphere is what I'm going to use to approximate that. So the volume of the sphere is equal to 4/3 pi r cubed. So we need to find what our radius is, and the radius is half the length of the diameter. So half of 22 would be 11. So the volume of our soccer ball would equal 4/3. And they said use pi approximately to 22/7. So I'm going to use 22/7 times 11 cubed. And we're going to come over here to our calculator. We're going to type in parentheses 4 divided by 3, close parentheses, times parentheses 22 divided by 7 for our pi approximation, times 11 x to the y 3, which is 5,577.5. So the volume of the sphere is approximately 5,577.52. And round your answer to the nearest whole value. So, this 0.5, I'm going to ask myself it's higher than, well, it's 5, so that means it would round that value up to 8. So 5,577 and 0.5 is closer to 5,578. So it's approximately 5,578 centimeters cubed. So 5,578 centimeters. So Rachel wants to slice her homemade loaf of bread into hexagonal shaped slices. Rachel's pan is in the shape of a rectangular prism. The bread is shaped more or less like the pan. Can Rachel use one slice to create approximately hexagonal shaped slices? Yes, a hexagonal shape is a six-sided shape, and since a rectangular prism has 6 faces, you could create a hexagonal shape because you would have to connect each of the faces. So you would have to connect the top, section of the top, a section of the bottom, a section of the side, a section, my perspective just shifted. There we go. A section of this side, the front face, and the back face. So the side to the top is one side length. The top to the back is one side length. Back to the front is one side, to the side is one side length. That side to the base is another side length. The base to this front face is another, and then the front to the side length would be another one. So you would have 1, 2, 3, 4, 5, 6. You could create a 6-sided hexagonal shaped slice. So yes, a rectangular prism can be cut because there are 6 surface areas, so you could connect each surface area and make that cut be a hexagonal shaped slice. Question 4. To create a bulletin board, Marianne is planning to stretch fabric from burlap sacks over cardstock. She collects 6 kilograms of burlap sacks. The area density of burlap is 0.4 kilograms per meter squared. What is the maximum area of the bulletin board that Marianne can make? So they give us a proportion here, 0.4 kilograms per meter squared. So I'm going to set up a ratio, and since I want to find the meters squared, I want to make sure that I'm going to use the reciprocal. So I'm going to set it up as 1 meter squared per 0.4 kilograms is going to equal an unknown amount of meters squared for 6 kilograms. So since we're solving for our x right here, I'm going to multiply both sides by 6 kilograms. So then 6 kilograms times 1 meter squared divided by 0.4 kilograms is going to give us 6 kilograms times 1 meter squared divided by 0.4 kilograms. Now, kilogram to kilogram can reduce down to a 1. So then our units left would be meters squared, which is what we need. And so in my calculator, I'm going to type 6 times 1, because those are my numbers. 6 times 1, which is 1. 6 times 1 is 1, and we're going to divide it by 0.4, because that's still the number in the denominator. So we're left with 15 meters squared. So on this side reduces down to 15 meters squared equal to x times 6 kilograms over 6 kilograms. Now we can reduce this part down because 6 over 6 is a form of 1. Kilograms over kilograms is a form of 1. So we have 15 meters squared is equal to 1x, or x in math. So Marianne can make a total of 15 meters squared. Okay, Marianne's friends loved her bulletin board, and 4 of them asked her to make one for their homes. She offered to make each of her friends a replica of her bulletin board that measures 2 meters by 3 meters. How many kilograms of burlap should Marianne collect to complete the bulletin boards for her friends? Okay, so it measures 2 by 3. So we have a 2 by 3. So the total area of this would be 6 meters squared. So for one board, she needs 6 meters squared of burlap. So they need 4 of them, so I'm going to take 4 and times by my area, which is 6 meters squared. So the total area she needs is going to equal 24 meters squared. Now we're going to use the area density again. And this time, since we are finding the kilograms of burlap, and kilograms is in our numerator, I'm going to leave it as is. So we have 0.4 kilograms for every 1 meter squared. going to equal an unknown amount of kilograms to 24 meters squared. So since we're solving for x, I'm going to use the multiplication property of equality and multiply by 24 meters squared to both sides. And so we have 24 meters squared times 4.4 kilograms divided by 1 meter squared. Since you multiply numerator to numerator and denominator to denominator, this does have a denominator. It's a Ninja 1. Can't see it, but it's there. So I call it the Ninja 1. And then x times 24 meters squared, that's our numerator. Denominator for this is, again, a Ninja 1. So we have 24 meters squared x divided by 24 meters squared. Now we do have forms of 1. On this side we have meter squared over meter squared. That reduces down to a form of 1. So then we have 24 times 1 times 0.4 kilograms divided by 1. And dividing by 1 will not change its value. Equals, we can reduce this side down because 24 over 24 is a form of 1. Meter squared over meter squared is a form of 1. And I'm left with 1x. So then in my calculator, I'm going to type in 24 times 0.4. The reason I didn't include 1 is because multiplying by 1 does not change that value. And so we can just take 24 multiplied by 0.4, which is 9.6. So we have 9.6 kilograms needed for 24 meters square meters of fabric. So she needs 9.6 kilograms to cover 24 square meters. Okay, question 6. Zed is making a centerpiece for his dining room table by putting sand in a cube-shaped vase. The vase is 0.25 meters in length, or a quarter meter in length, width, and height. He bought 25 kilograms of sand. Assume the density of dry sand is 1,602 kilograms to meters cubed. What is the volume of the sand that Zed purchased? Okay, so we have that he bought 25 kilograms of sand, and here is our density of dry sand. Now it's kilograms to meters cubed, and volume is in meters cubed. So since meters cubed is in the denominator, I'm going to use the reciprocal and property and rewrite it as 1 meter cubed is to 1,602 kilograms. And I'm going to set up a proportion is going to equal an unknown amount of cubic meter sand, to 25 kilograms. So again, we're solving for x, so we're going to use our multiplication property of equality and multiply by 25 kilograms. And multiply by 25 kilograms here. And we multiply fractions, numerator to numerator, denominator to denominator, and there is a Ninja 1 denominator here. It is implied. So 25 kilograms times 1 meter cubed would be 25 kilograms meter cubed divided by 1 times 1,602 kilograms is 1,602 kilograms. That's going to equal x times 25 kilograms is 25 kilograms times x divided by 25 kilograms times 1 is 25 kilograms. So now I can reduce forms of 1. So kilogram to kilogram is a form of 1. Kilogram to kilogram is a form of 1. 25 divided by 25 can be reduced down to 1. So I have 25 times 1 meter cubed. So 25 meter cubed divided by 1,602. And that's going to equal my unknown cubic meters. So let's type over to our calculator. 25 divided by, 25 divided by 1,602. So he bought 0.0156 cubic meters of sand. So on this it says enter your answer as the number that correctly fills in the blank in the previous sentence. If necessary, round your answer to 6 decimal places. Okay, we better go back to our calculator and go to 6 decimal places. So 0, 1, 4, 5. Okay, since this 4 is 4 or lower, that 5 does not change. So I need to add 605 right there. So it was 0.015605 cubic meters of sand. Z is making, so refer to the previous question, Z is making a centerpiece for his dining room table by putting sand in a cube-shaped vase. The vase is 0.25 meters in length, width, and height. He bought 25 kilograms of sand. Assume the density of dry sand is 1,602 kilograms to cubic meters. Use your answer into the previous question to help determine which statement about the sand and the vase is true. Alright, so I would recommend finding the volume of the vase. Since it's a cube-shaped vase, we know that the volume is the area of our vase shape times the height, and since the area of the vase shape is a cube, sorry, this is not a cube, but it's all the same. So this is 0.25, this is 0.25, and this is 0.25. So the area, the volume of this is going to be 0.25 cubed. So the volume of our vase is going to equal 0.25 cubed, meters cubed. So we come over here, we type in 0.25, x to the y, click cubed, it equals. That's going to equal 0.015625. So now if we come back to our course player, the volume of the sand was 0.15605. So it is less than the volume of our cube, so it will fit in it. So the sand will fit in the vase because the volume of the vase is 0.015625 meters cubed. So yes. It will, and since the volume of the cube is greater than the volume of our sand, it will fit. Alright, so your help tip for today is called the H7 points. I identify it by your wrist bone right here. It is 1 finger width below it, and it's actually on the inside of your hand right here. And if you rub that, it's an acupressure point as well that will help relieve stress and anxiety. So again, you could be doing all of these tips that I've shared you with as you read through a problem. If you're on a test and you feel anxious all of a sudden, these are great ways to just help you stay calm and focused on the material and to help give you your best chance. So again, it's on your wrist, it's on your pinky side, and I identify it because I have a really bony wrist right here protruding, and it's 1 finger width down, and it's right on the inside, right there. And you just rub it, and take deep breaths through your nose and out through your mouth.